talking about subnetting and how can we find the IP range if we have the IP address and the subnet mask. So we assume that we have the IP address 10.10.10.10, which is this one, 10.10.10.10. Okay, we see that one. We see that with /21, it is in the range of from 8 to 16, 8.0 to 16. All right, cool. That's cool if it's 21. Let's see how it is. 21, 16, 8 to 16. Those here are the network's chunks. All right, those are the network chunks. So if you see, for example, let's say number 40, so you have 10.10.40.10, and you see that if it's /19, it's going to be within this chunk. It's going to be within this chunk. So the first IP address will be 10.10.32.0 until 63,255. Okay. So it's going to be within this chunk. It's very easy because it's /19 and it belongs to this small chunk. Let's see. You see? It belongs to this chunk. Sorry. This one, 40, 10. So you see from 32 to 64. Okay, this is when it's /19. Let's take another one, 10.10.100.10. Let's take that one. Say 100 is this penultimate octet. You see it belongs in this chunk, in this piece of network. This is the network it belongs to. So if it's /18, we have from 64 to 128, right? 64, 128, perfect. Let's say it is 200 with /17. What happens? 217. All right. You see from 128 to 256. All right. 128 to 256. This is the range. Is this the range here? Yes, it belongs to that range. If it is /17, this is very important. It has to be /17. All right. Okay, that's perfect. All right. That's very easy to do with this small table because you know the chunks and you know like 200. Okay, it belongs to this chunk. If it's /17, you know immediately in which chunk, in which piece of network it belongs. You know, you can identify very easily the network ranges if you are using that table, because you immediately know, okay, for example, this is 3. This is 3.10. Okay, imagine this is 3. If it's /23, it's super easy. It's going to be, I can tell you immediately, it's going to be 10.10.2.0 until 10.10.3.255. Yeah, the range. You see how easy it is if you have like this IP address and this number is within the range and it's slash 23, you know immediately. You can tell immediately in which chunk this IP address, this octet, this byte is, in which range it belongs. The same is for, let's say, 6, 5, or 6 or 7. Those here in between, you know immediately where they belong. All right. So it's super easy. The problem is when we have like 3 here, like that 10.10.3.10 as an IP address, and it is said that it belongs to the range, uh, like it belongs to the subnet. It has the subnet mask, the CIDR uh, subnet mask slash 18. For example, let's try that out. Let's try that out. We have, let's change it here. 10.10.3.10. And what did we say about the, but we said it's going to be 18. Okay, 18. And look what happens. It's from 10.10.0 to 64. From 0 to 64. So this IP address belongs from in the range from 0 until here. You see? You see what's happening? Because it's slash 18. Okay? So what happens? What happens if we have slash 18? It means that this guy belongs to this whole chunk, this here, from 0 to 64, this here. Crazy, right? So basically, if you have like the rule is when you have, like, for example, slash 19 for 3, you see, okay, it belongs here, but it's slash 19. So the range is from 0 to 32, you know? So the chunk is that big, from 0 to 32. All right? This is actually incorrect. It should be, sorry, it should be slash 0. Okay? Same here. I did a little mistake. Okay? So you see how this works? If you are within this chunk, it's very easy. Like I said, for example, you are 30 with slash 20, you know immediately. Okay, it's here. But if it's 3 with slash 20, you know it's from 0 until 16. That's basically the subnetting. This is super important to have that one, to know the chunks, and you know immediately when you have that one memorized in your mind. For example, that slash 17 is this one, is this chunk, slash 18 is this chunk, slash 19 is this chunk, slash 20 is that one. You can do IP ranges immediately. You know immediately from where to where. I hope that was a little bit useful. And since this is not using any formulas, any like maths, or like any, you just have to understand like the chunks that are here, the subnets, and then you're able to calculate everything. So even though later on, if you memorize this um, notations, side notations, you are going to be able to do ranges by heart. Just someone tells you an IP address, whatever IP address, you'll be able to immediately know within what range, within which chunk, within which network chunk it's going to belong. Any IP address from 0 to 256, you're going to be able to immediately classify it. Someone tells you it's 3, you know immediately, okay, /23 in this case. Otherwise, if it's in this octet, um, for example, someone tells you /28, you know immediately it belongs to 32 to 16. Okay, so if you're able to just relate this um, slash whatever number to a specific chunk of network, it's going to be super easy because these guys are very confusing. /24, they don't mean nothing. They mean nothing, absolutely nothing. They're just they have no logical representation. But if you are able to memorize to organize these chunks in your brain, these segments, these network segments in your brain, you're going to be able to calculate without any problems the the subnet, the IP ranges. In case you are in some environment where you don't have this subnet calculator, you have to do it by heart, like only using your brain. You can use it only by knowing this specific network chunks. They're super important. This is the most important thing. These guys here, not the /17, /18, /19. These are the important ones. You have to know what's behind it. Which network component, which piece of network is behind /17. You have to be able to know. Okay, /17, from 128 to 156 immediately. If someone tells you 20, okay, from 16 to 32 immediately. All right. So if you can organize those here, these relations here in your brain, everything is going to be fine. Thanks for watching. So let's take another example with this table. We can very quickly figure it out. So we're going to take again 10.10.100.10 is our IP address. And this time, as subnet mask, we're going to choose /23. Where is /23? Here. So we're going to have the range from 2 to 4. So which is 2, right? 2. Our subnetwork is going to be of this size, 2. 512 hosts. 500 is going to accommodate 512 hosts. So it doesn't belong here at /18. This one belongs actually here. But in that case, if it's /23, the network is a lot smaller. So I believe it's going to be in this size, 10.10.100.0 until 10.10.102. But of course, we stop at the penultimate IP address. So we have 10.10.100.0 until 10.10.101.55, right? Normally we have to subtract this one, .0 and 55, 55 for the broadcast and .0 for the network IP address, but I'm including them as well. So this is the range of IP addresses that we would have in this case. If it's 10.10.100.10, this is going to be the range of IP addresses that we're going to have available. Of course, we have to first subtract the network and the broadcast IP addresses. But never mind, just to illustrate. Let's check if this is so. We have 10.10.100.10 Cedar notation /23, right? In subnet mask is going to be 255.255.254.0. And what happens here? Usable host IP range 10.10.100.1. Like I said, this gets subtracted until 10.10.101.254. So we have the size of 2, right? From 100 until 102, basically. This is what we have as a chunk, right? Total number of hosts, 512. Usable hosts, 510. All right. So this is how you can do it using this table. This table is the best. All right. So you can always know what what size your network gonna be if you take a look at the /23. So we have it somewhere here, but it's gonna be the size of 23, right? So we're gonna have many small networks. All right. Thanks for watching.